Hello everybody and welcome to the last session of our open day. This is especially for parents and supporters, and we have Professor Caulfield is, sorry, I've had a long afternoon. Professor Caulfield is our head of department in Applied Maths and Theoretical Physics. He is also an admissions tutor at Churchill, and he lectures in our department, and he'll be able to answer all questions you have. But first of all, we'll have a presentation by him, and there will be chance for all of you to ask questions at the end. You have an icon at the bottom that says Q&A. Please use that to type in answer, and we'll try to answer as many as possible. I'm sure it won't be possible to answer all your questions now, but this is going to be recorded, so we'll try to answer questions afterwards and to collect all the question and answers in something that we will put on our website. So I'll just let Professor Caulfield talk now.
Okay, thank you very much, Ursula, and welcome everyone virtually to Cambridge. My name's, as Ursula said, my name's Colm-cille Caulfield. I'm the head of department of one of the two constituent departments of the Faculty of Mathematics. There's the Department of Applied Maths and Theoretical Physics, and also the Department of Pure Maths and Mathematical Statistics. And we're both lucky to be housed ordinarily in this very nice set of buildings, the Centre for Mathematical Sciences that you can see in this particular picture. Just one little correction. For 5 years, I was indeed one of the admissions tutor at Churchill College, but I'm not at the moment. I'm quite busy enough with being head of department. So please, I see already people are typing in questions, and that's great, and we'll try and answer them as we go along. And indeed, one of them that I will already manage to address, a question of is a certain number of places reserved to applicants outside the UK, or only after filling all places by strong UK students, then students from other countries are accepted? Well, in a typical year, we accept about 200, we aim to have about 250, 255 students. And typically, it works out to be about 150 a home, and the rest are from both other nations in Europe and then further afield. But there isn't a quota particularly organised. And indeed, those decisions are made by colleges. And then there's also a question about should applicants do 3 or 4 A-levels, and they should do the A-levels that they like. We can see that further coming along. We do certainly want people to do maths and further maths, and typically one other A-level, but we don't discourage students doing a 4th one. Certainly not the case. Okay, so let me see if I can manage to do this without human contact. Like I said, there's time for questions, and also please see this studying at Cambridge booklet. And as you can see, that is the top of the central core of the Centre for Mathematical Sciences, and it is very, very reminiscent of something from my children's childhood, of a certain Teletubby land. And also, it's also very important for me to have the disclaimer at this stage that please check what's in the printed literature, the documentation. I will, of course, try and only tell you the truth, but for particular details, please do check the written documentation. So, what do you expect, or what could you want if you wanted to come and study mathematics in Cambridge? Well, of course, Cambridge is really quite different, and one of the big questions that you should be thinking about addressing at the moment is about whether it is right for for the person that you're here to be supporting. Questions that you might wonder about is, will they fit in? Will they enjoy the course? Will they do well? Can the unit afford the process? And well, so how could you, if they love maths and really enjoy working at maths for maths' sake, of course they'll fit in. Where I have often given the first lecture for, in the first year course, indeed, I've been privileged enough to give the very first lecture several students given. There's 250 enthusiastic students out there looking at me. And I sort of say, you know, welcome to the tribe. This is really such an amazing opportunity to be surrounded by people who really just love maths and have loved maths and will do it for the enjoyment of doing the mathematics. One of my favorite UCAS forms on the personal statement of one of the students that I ended up teaching at Churchill, when they had asked to fill out the, the bit that you fill out at the bottom saying, what is, you've got to have extracurricular activities written down. And their extracurricular activities was one single sentence saying, in my spare time, I like solving maths problems. And that sort of person is just exactly the sort of person that you might want to have, that we would have in Cambridge. Will they enjoy the course? Well, if they like doing amazing mathematics, being taught by amazing people and being surrounded by other brilliant students, then this is a great place for them. But then, of course, the question about these that we're talking about, that you're thinking about now, if they're typically year 12, is, are they right? Is the student right to come to Cambridge? So really the thing is, will they be able to thrive within the Cambridge program? Because it's really quite demanding, quite fast paced. And really we try and have it at the very highest international level by the end of the 3 or 4 or often 4 years. For the students, they really should be right at the forefront of mathematics, and so really part of our assessment is seeing if they're the sort of person who's likely to thrive in this environment, which has very fast-paced teaching, relatively short terms, very demanding content of the course. And so really part of the assessment we want to determine is whether this is the right place for the students themselves to actually come to. So what is special about Cambridge, apart from just having Teletubby land? Well, we're one of the broadest and largest faculties for mathematical sciences in the world, and it's very broad. Our mathematics, you'll notice from the name of my department, it was the Department of Applied Maths and Theoretical Physics. Stephen Hawking was a Lucasian professor in our department. So we have a very, very broad definition: theoretical physics, quantum mechanics, cosmology, and such like is taught within our undergraduate program, but also very pure mathematics, number theory, geometry, category theory, very broad definition of what we mean by mathematics. Indeed, my personal interest is in fluid mechanics. We have courses in fluid mechanics, courses in waves, the important question of why do the waves have the particular shape they have behind a swimming duck. That's one of the things I lecture about. And so we have this very, very broad set of opportunities for students to study a very, very wide range of subjects that at their core are mathematical. So between the two departments, there's about there's over 110 or so university teaching officers. For the research excellence framework that we're doing, there's about 160 people who are being listed as active independent researchers in between the two departments. There's a very, very broad range of specialities that's therefore available. In our third year course, there's the third year of the undergraduate program, which somewhat confusingly is called Part 2. We have about 35 different courses that are given, and the students can choose any of them. It's an amazing opportunity to delve into a particular area of mathematics that you're interested in. So you could, in the third year, you could be specializing essentially in theoretical physics. You could be specializing essentially in statistics or data science kind of subjects. You could be specializing in pure subjects like number theory, geometry, analysis, and so on. So you have the opportunity to really go in depth, but to a very broad range of subjects. It's an amazing opportunity. And we think we're very strong in our research. We're very dedicated to our teaching. I certainly have an amazing set of colleagues, but it's also very important to appreciate that the thing we really have a fantastic resource here is our students. Indeed, whenever I have been involved, I recruited a very good friend, was involved in recruiting a very good friend to a professorship in the department, and I was saying the biggest selling point is that just the students are amazing. It's such a joy to teach such amazing students. It's such a joy to be to supervise and mentor such amazing students at the research postgraduate level. And it's just a fantastic place. And so it's very, very, the quality of the cohort of our students is great because everybody loves maths. And so it's really important that we try and choose and select people who will thrive within this particular environment. So that's what we really aim to do. And so, unfortunately, you haven't had the opportunity to come and see the whole Hogwartian splendor of Cambridge. But of course, it's distinguished by its history. You know, it's been around for over 800 years, by the collegiate structure that the students, every student is associated with a college, and comes to where the college does the small group teaching and accommodates the students, and there's this wonderful communities in the colleges. And the university, of course, many people have jobs both in college, have the connections both to colleges and to the university. You know, I'm a fellow of Churchill College, I do supervisions in Churchill College, I've been involved in interviewing and so on at Churchill College, but I'm also a member of the university department where I lecture, where I do the examining, and I'm involved in the research activity. And so, the collegiate aspect, that you can be part of a smaller cohort, you know, typically, as I said, there's about 250 math students every year. But because we have the, you know, 25 or 30 different colleges, each college has a group of students that's relatively small. So, well, I mean, Trinity is exceptional in many ways. Trinity has a cohort of 40 or so. But most typically, the colleges have a cohort somewhere around 10 each year, which I think is really wonderful, because means that you have a group of people, an immediate sort of friendship group that you bubble, as in the new words, of students that are doing the same subject as you, so that you can talk and work on your problem sets and so on with. But then you're also part of this very much bigger organization and the big organization allows you to have this wonderful range of different courses available to you, and the breadth of sort of things you can do. Now, also, the culture is very important. And I don't mean the culture that I want to really focus on is not the wearing of a gown and having formal meals, though that can certainly be fun, but it's a culture of real love and interest in academics for its own purpose. The acquisition of knowledge is really at the heart of activity in Cambridge, and it's really a cool place to want to work hard and want to learn a lot of things, and it's just an amazing environment for that. And then also, bluntly, the fact that there are various bits of endowment means that the education that you get here, even with the fees paid, is quite subsidized, because the level of small group teaching that we're able to provide, and also the number of staff we have, the academic staff we have for the number of students we're teaching, means that we're able to really put on a broad range of courses and also have a lot of individual attention for the individual students. So they get an awful lot more, a lot of teaching availability. So, and of course, I keep coming back, the best thing about the place, one of the great things about the place, is how good the students are that we have here. So how do we choose the students? Well, there's of course a policy position, and we want to offer admission to the students of the highest intellectual potential, irrespective of social, racial, religious, and financial considerations. So it's very, very important to appreciate what's being said there, and perhaps with this, every word there is chosen with care. You'll notice it is about potential. We want to admit the students who have the highest intellectual potential, who will have the opportunity, who have the potential, the ability, the background to gain the most from having attended here. And also, it's irrespective of, it is a financially independent view of whatever the situation is. We're not going to we don't admit somebody because we think they can pay or not pay. We admit because we think they're the students who have got the best possible opportunity. We also have two further aims. We aspire to enhance it's the correct view of, you know, equality, diversity, and inclusion. We want to encourage applications from groups that are at present underrepresented, because we don't want any, but we want to admit the very best students, and the most logical way to admit the very best students is to be able to choose from an application pool that has a representation of the very best students. And if there are some groups of some distinguishing characteristic that are not applying to us, that is not good, because then we don't have an opportunity to recruit the best from that particular cohort. So that's certainly something that we're very keen on. And of course, we're very keen on fairness. We want to ensure that each applicant is appropriately and individually assessed, no bias or partiality, in accordance, of course, with equal opportunities. And a particular detail, which is a common one that might come up for people from parents, etc., advising the kids, particularly maybe from situation, one of those groups that doesn't typically apply, is to ensure as much as was humanly possible that the applicant's chance of admission does not depend on the choice of college. Now, it is important to appreciate that that doesn't mean that the chance to get into any individual college is not controlled, but we have calibration mechanisms through things we call the pools, which I'll come on to talk about a bit in a moment. Through the pools, that means that if you apply to college A, and college A in some sense is full, you then have the opportunity the pool then moderates this process and says, well, maybe college B will take you. And that process works extremely well, kind of screws up the immediate period after New Year, but it works very, very well to ensure that the best end students get into Cambridge for the particular course, irrespective of which college they happen to have applied for. And so that is a really important thing to stress. Don't look at the numbers of the number of places in a college divided by the number of direct applicants to that college and try and infer from that information which college is easier to get into. It just doesn't work that way. That's not the principle, because we have this moderation process. Now, I've started to mention ratios of numbers. What are sort of numbers that we might have involved? There's typically 5 to 6 number of applicants for every place in mathematics. And we have a very detailed and labor-intensive and careful process by which we select from that group of students. And so I'll talk you through that process now. If I press my buttons right. So, what is it we're looking for? We're looking for real enthusiasm and interest and enjoyment of mathematics, because you have to work hard when you get to Cambridge, no matter how good you are. And indeed, very commonly, the situation is people who are good enough to come to Cambridge are actually finding school mathematics quite straightforward. And so there has to be a real love for it. It's not that, and a very interesting point in one of the videos, which I would encourage you to look at, one of the previous students whose video had a very good point about this. Students may enjoy mathematics at school because they're good at it. But the sort of students we want are the ones who enjoy mathematics and are good at it. And there's a subtle difference there. The point is that they really have to love doing the mathematics, and if it becomes challenging, they'll still, oh wow, this is great, now I've got to think even harder about it, and I've got to think even more about maths, it's fantastic. That's really the sort of students we want to have, the ones who really love mathematics. They have to be good at it, they have to have some core knowledge, but it is very important to stress that potential is a key detail. They have to be intellectually flexible, be able to think outside the box, or if they get stuck, think a different way. Mathematics is actually a very creative subject, and that's got to be remembered. They've got to have a great enthusiasm, got to be enthusiastic about it, and they've got to be motivated to keep working. Because once again, everybody finds Cambridge difficult, or university mathematics is harder, and so you've really got to be prepared to work through these things. So the way I summarize it, and it sounds maybe a little unpleasant, something to remember is that what the candidate we're looking for is tips. They've got to have talent. They've got to actually be really good at maths. They've got to be really interested in maths. They've got to demonstrate some level of performance. We do look at the exam results. You have to be able to, pass the step exam and so on. There's got to be some evidence of performance, but also there's got to be evidence of hard work, because it is hard work when you come to Cambridge. So you've got to be prepared to sweat and indeed enjoy the exercise. Like some people, people like running marathons, but you've got to exercise to be able to run the marathon. But it's fun to do the exercise and fun to do the marathon in the end. That's the sort of student we want to have to do the maths marathon. They want to love doing maths and getting better at maths, and not think it's hard work to have to do many, many step questions to get better at it. So that's really important thing to bring home. Because, and of course, we are dealing with the people that we choose to admit, of course, but it's fun to teach hardworking, enthusiastic, great students. So that's the thing to do. So what sort of information do we use in the process? Well, we use the academic record. That's very important. As I say, one thing, the Cambridge, we teach to a very high level, and we teach very fast. We have 8-week terms, they're really quite short, and there's a lot of information comes through in the examinations. And also our assessments are typically based around end of year exams. There is some computational projects in second and third year, but end of year exams is what we base our judgments on. And so therefore, for you to thrive in Cambridge, you've got to be the sort of person who's good at taking end of year exams. And if you're the sort of person who's good at taking end of year exams, there will be evidence that you are good at taking end of year exams. So that's the principle that we're really interested in. Also, the school reference is very important. The teacher has to describe well the properties of having talent, having interest, and being prepared to be intellectual flexibility, and being prepared to be hardworking. These are all things that we need to know about, and these are the things we're looking out for. For us in mathematics, the personal statement isn't such a big deal. We want to see that there is an interest, but we appreciate we're not admitting people based on their ability to write an essay. We're based on admitting people who are interested in their mathematics. The contextual data, of course, is very important. Being one of the best students that the school has ever seen is a very strong indicator for us. And if you are overcoming some level of difficulties, if you come from an area where there's relatively small proportion of people go on to higher education, or perhaps go on to higher education at highly selective institutions, then that feeds into the way we assess people. And then also the performance of the interviews, and that's very important. Now, also, unusual, we have the offers that we give are based around this 6-term entrance papers, the STEP. 6-term examination papers. I fear I might not have put the right thing there. And those are papers that are taken after A levels, in the late June. And we typically require people to do step 2 and step 3. Our typical offers involve performance on step 2, II, and step 3. And those are, the questions on those papers are very much better representative of the sort of mathematical testing, the sort of mathematical reasoning that we want people to have, or that people have to experience when they go to university. And so even if your child doesn't get into Cambridge, it still is an extremely good thing to have worked on the STEP papers, because it is very representative of the sort of work that they will be doing when they get to university, much more than A-level questions, which are, I like to sort of describe that they're somewhat reminiscent of a slalom in skiing. You do this, then you do that, then you do this, then you do that. And you kind of, there's a rhythm and a structure to the way they're done, which is an entirely appropriate design of an examination. Mathematics is often taken by people who want to do medicine, want to do engineering, want to do physics. That I'm not criticizing the design of A-level, but the thing is, it doesn't have the synthetic combination of different ideas, and also the necessity of evidence of creative thinking or flexible thinking that we really need for people to be able to start where we want them to start and be able to absorb the information in the speed at which we teach it. So that's a really key part of why we use the STEP exams, and set our offers typically based on the STEP exams. So that's really what I'd say on this slide. We think it's a very good preparation for university mathematics, and I would just recommend every child who is seriously thinking, every year 12 student who is seriously thinking of doing mathematics at a research intensive university, one of the top ranked maths universities, that it's really a good idea to be just practicing the STEP. And they're cool questions, they're interesting questions. If you're interested in mathematics, you should like solving the puzzles that are at the heart of the STEP. And so that's what we think. Now, I'm not really one for getting into dark blue, light blue comparisons, but I'm guessing many of the people here are thinking, well, what's the difference between the Cambridge system and the Oxford system? And in the admissions, there's a somewhat different strategy. We think sitting STEP is a very good thing to do, and we think doing the STEP exam is a good test for your subsequent good preparation for university. And so our pattern is typically we interview about over 3/4 of the students who apply. We give a lot of offers to those applicants, but many students who get an offer do not in turn get admitted. You know, ballpark figures, 50 people apply, about 500 get offers, about 250 come, right? You know, rough sort of figures. And that is the way that we believe it's an appropriate way to go. Oxford does a somewhat different approach, that they filter a lot. They do an admissions test, and so they have a substantially smaller number of their cohort get invited to an interview, and then at the interview stage they effectively make the decision of admission. Pretty much everybody who is considered does actually make their A-level offer. And so I would argue that puts more weight on the interview than we do. We put a much more weight on a performance in an examination, which we believe is A, highly correlated with subsequent performance at university, and B, is very good preparation. The studying for it, the training for it, the thinking about that course, is those exams, is the correct way to enhance your mathematics studying while at school, to then be better prepared for starting university. So that's why I think our way of doing it is the right way to do it. So what's the typical offer? Well, our typical offer in terms of A levels is 2 A stars, though there are some 2 A stars, and then at least a grade 1 in step 2 and step 3. Now, the grading is a bit idiosyncratic, shall we say. The grading in step papers goes S, 1, 2, 3, and U. So what grade 1 is equivalent really to a B. It's the second level of the grades, and you're asked to do these examinations are quite similar to university examinations. They're 3 hours. You're asked to do 6 questions. A 1 is typically getting about 4 of those questions largely outright. It varies from year to year because it's actually kind of norm referenced. It's not criterion referenced. We kind of ordered the students the number of ones we give out. But the typical offer is 2 A stars and at least a grade 1 in step 2 and step 3. But we are now also introducing a flexible offer, as is written down here. Some of the colleges, Downing, Emmanuel, Fitzwilliam, Jesus, King's, Lucy Cavendish, Newnham, Sydney, Sussex, and Trinity Hall, I think, but once again, check the documentation to get it right, are introducing this flexible offer because there was a thought that the ability to prepare for STEP in different environments is different, and some people might be more concerned about STEP. So but whereas you can do well in your A level, so that is the alternative offer for some colleges is to do a 3 A stars, but then just a grade 1 in one of the 2 papers, either step 2 or step 3, though of course we would encourage people to take them as well. And this is an intention, an effort to encourage and boost the diversity of the admitted cohort of number of students, and it seems to be working in the desired fashion. And so you see the approach for these offers is that you're asked to do well in STEP and also well in your A levels, because once again I keep coming back to the point, how you're doing the examinations is a key point. Now, college choice. Now, as I said, it really doesn't matter which college you apply to in principle for the admissions, and I really would discourage people from really sweating too much about that. Now, you don't even have to put down which college you which you apply to. You can if you put in an open application, then a college that has a relatively small number of mathematics applications for the number of places they want to allocate, that college will get that open application allocated to them. And then the applicant will be treated as if they had applied directly to that college. And the initial process of admissions is, well, it's all governed by the colleges, but you apply to the college, or if you apply to an open application, you are allocated to a college that has a relatively small number of applicants. You go through the files. As I said, about 3/4 of them are chosen to come to interview. Most colleges have some kind of written test is done while you're there. That feeds in as possible things to talk about in the interview, different ways to compare people. And then a decision is made about the people who directly applied. Maybe they'll get an offer, maybe they'll definitely be rejected. But as it say here, there could be that, well, this person looks really good, but we did, by a statistical anomaly, we had relatively really strong candidates this year. So we're going to put this candidate into what's called the winter pool. And then in January, all the directors of study, all the different colleges come together and look at the files that have been put into the pool and see, well, do I think that an applicant in the pool that applied directly to another college is better than the ones at the bottom of my list at my college and my original direct applicants to my college? And so then I'll swap them round. And that's the process that we do. And there's a meeting where we have something that's very much like the American football draft. We'd say, first college, we have a set up an order, and then a college selects a student to give an offer to, then the next college, the next college, the next college, and so on round. And as it says here, typically about 30% of our offers come out of the winter pool. There's easily over 100 offers are made in the pool. Many students come out of the pool. And as I delight in telling, my greatest achievement in the winter pool was actually to select somebody in the pool who went on to be senior wrangler, i.e. come top in part 2, and is now doing his PhD in Princeton. But that was, I never ceased to remind my colleagues at the college that pooled him what happened. So it's no shame to be taken out of the pool, and students do just as well who were in the pool as otherwise. And then there is a further stage after the step results are known. Students are pooled who missed their offer, and often students who missed their offer are further taken. And indeed, easily 20%, 30% of the students have actually missed their step offer, still end up coming. It's only about 150 or 160 of students get 1-1 or higher, and yet we still have a cohort of 250. But then there is a decision at the summer pool about different colleges about which ones just missed their offer and whether we would want to take them, or whether a particular college will take them. So that's the process by which this phenomenon happens. So what do we offer? Of course, we have fantastic, we would like to say, we have fantastic teaching. There's fantastic student support, financial support, guaranteed accommodation. That's a real big plus. Every college will guarantee you accommodate, particularly for the parental units, will guarantee you accommodation for all 3 years, indeed pretty much now 4 years. And it's short terms with a good landlord. This is a key detail, right? The students rent the rooms for 30 weeks rather than having to sign year contracts with private companies. Indeed, the terrible crisis we're in at the moment is showing, colleges have just, said to the students for this term, no, you don't have to, you're not being held to your contract. So it's very good environment. And of course, very, very good career prospects are available. Cambridge mathematicians are very commonly taken. And there's another real attraction to Cambridge, which is not sort of widely thought of. There are so many different university and also college clubs and societies, because you have these small units of several hundred. Churchill has 450 undergraduates, shall we say. So the college can have, has a jazz band, has soccer teams, cricket teams, rugby teams, hockey teams, and many, many rowing boats. And so if you'd like to play football, but you're not going to necessarily play for the university, there is a team available for you to do that. There's some music opportunities available for you to do that in these smaller communities, which is just fantastic that you have this small community, as well as the college community, as well as the broader university community, as well as your subject. There's a load of different, there's a Trinity Maths Society, which still allows other people to join it. There's a Maths Society at St. John's. There's a Maths Society at Queen's. There's a University Maths Society, the Archimedeans. And there's a women, the Emmy Noether Society for women in mathematics. There's all these different groups that you can have of people with like-minded interests. Every college has an ultimate frisbee team. Who knew that was a thing? But it allows you to have all these different activities, and that then means amazing friendships can be formed. So just as of course I want to stress that we have and Cambridge is a very booming city as well. That's another thing to be said. We have a great amount of the penumbra of the university has really got a Cambridge cluster of high-tech companies, and it's very well connected to London, and so it's a really dynamic place to be. So what do we provide? Well, we give fantastic lectures by my colleagues, and a typical rhythm of the students, let's say in first year, there's a rhythm of 12 a week lectures through Monday to Saturday, 10 to 12 at Monday to Saturday, with 2 supervisions associated with that. Now, what does supervision? You have in the first year, there's 4 courses before Christmas in the Michaelmas term, 4 courses in the Lent term after Christmas. And so you have running Monday, Wednesday, Friday, you have lectures from 2 courses. Tuesday, Thursday, Saturday, you have lectures from 2 different courses. And so in any 2 weeks, you have 6 lectures for an individual course. For each of those 6 weeks, you're given an example sheet to work through the problems. And then those problems that you've worked through, you have a supervision, this small group teaching, 1 lecturer, 2 students, 1 fellow, could be a PhD student, could be a postdoc, could be me. You go through these example sheets and these supervisions. So you'll be typically having 12 lectures and 2 supervisions, 1 for for every second week, you have a supervision for a course. And these are amazing because the students, as an educational guide, you've tried the problems, and then you have to be talked to about where you've got stuck. Now, in other places where you have example classes where there's 12 or 14, it can be the noisy students, but it's possible to disappear in those environments. But if you are sitting, the 2 students are here, and I'm saying, well, why did you get stuck on question 7? There's nowhere to hide. And so there's a great way for you to actually learn things, and you can really be helped in where you've got stuck or not. Okay, there's a very wide range of courses, like I told you, an amazingly broad range of courses. And the key thing is, though we have maths and we have an opportunity of maths and physics, really we say that no, you're coming here to just do mathematics. Most of the courses are either chalk and talk or via a visualizer, kind of writing on a tablet sort of thing. And that isn't because it's old-fashioned. We really think it's important in mathematics that you see the development of an argument through 20 minutes or so. So you want to be able to see, well, this is the start, this is the proposition, and then we have to have this lemma, and then we prove that lemma, and then we have to prove another lemma, and we've got those lemmas. And then when we've got those 2 lemmas, then those 2 lemmas lets me prove this theorem, and then so now I've got the theorem, and then I can talk about a corollary of the theorem or an example of that theorem, or I could in applied maths be saying, right, this is the sort of problem we want to solve. These are the sort of techniques that you use. This is the formal theory that will mean that we're able to solve those sorts of problems. This is the general way algorithmic way you would do it, and here's an example of doing that. And you want to be able to see the development of the story over multiple panels, and not in a way that is possible on a PowerPoint slide. So it's really important to see this idea of the argument developing over an extended period of 20 minutes with being able to look at all the different panels of a chalkboard. It's actually the right way to do it. It's not the old-fashioned way to do it. It's the right way to teach mathematics. Great libraries, and we demand an awful lot of the students in terms of how long they work. 40 hours, 50 hours, 40 hours during term is a very standard amount of work. So in particular, in the parental unit sort of situation, it's not really possible to have a part-time job. because it's the time that you have to do this course is demanding. We have fantastic teachers. Here are just 3 typical colleagues of mine. Julia Gogg, who's been very much in the news at the moment. She's on the Scientific Advisory Group for Emergencies and also the Scientific Pandemic Influenza Group on Modelling. She's one of the world leaders on the mathematical modelling of pandemics and epidemics. You might have seen her on television with Hannah Fry, sorry, not Hannah Fox. Hannah Fox is one of my colleagues. Hannah Fry, using cell phones to show how a disease could propagate through a community. Jack Thorne, professor in the Pure Maths department, who's just been elected the youngest at the moment, fellow of the Royal Society, and Coucher Berker, of course, who won a Fields Medal a couple of years ago. These are all colleagues of mine and all have been teach undergraduates. Okay, so you have these amazing lectures, and we expect you to work very hard. Okay, so I should come to an end. There's a little bit of, I want to talk about the student support. Like I said, there's nowhere to hide in terms of the supervisions, but it's amazing. The collegiate system really allows you to engage with the students. You have directors of every student who's in a college. There's a director of studies allocated who organizes these supervisions, who meets the students at the beginning of term, the end of term, gets to know them. When I was a director of study, I knew the names of all the students in any one year at Churchill College. Great thing, I knew what they were interested in, and I was able to write them reference letters about, and advise them, well, this is a good place for you to do a master's course. Well, I'll write you a letter of reference to go to this place or that place. Not only do they have somebody interested in their studies, but there was also a separate tutor who is involved in the sort of pastoral care, like the money worries, girlfriend, boyfriend worries. They are the health issues. They're the people who can help you out with that. Typically, every college has its nurses. The university has a disability resource center. There's typically counseling, often in the colleges provide this, and the university has a source, because we know that mental health is a major concern at the moment. And this particularly means that we have an extremely low dropout rate. Very, very few number of students fail to complete their studies at Cambridge, because though it's very demanding, there's a lot of support system around the various students. So it is a real issue nowadays that the mental health is getting, it's becoming more and more of a concern for young people all across society. But there is a very large investment in the university in supporting this, and because of the collegiate system and the university system, there are a lot of resources available that support. And the statistical evidence is, of course, that most students manage to complete, the vast majority of students manage to complete their studies. Okay, costs. The important thing to appreciate is that Cambridge is actually not a very expensive place to come to university for 2 reasons. One, the college system itself gives a lot of support to students who need it. There are various bursaries available in the colleges. There are various, both at the college level and the university level. And there's the education that the students are getting is a lot more expensive to provide than is actually covered by the fees, which is coming from a cross-subsidy via the collegiate system, which are charities themselves. And also the second point is that the renting, the time that you have to, accommodation that you get, you only have to rent it for 30 weeks in general. And the most colleges, it's only the 30 weeks. And the cost of those and you are renting those rooms off the college that is associated with you, which is not a private landlord. So the prices are not really that high. And there's another comparison point with respect to Oxford. Students live in all 3 years or 4 years if they do the 4-year course in Cambridge. That's a thing that happens. Okay, so we go, of course, mathematicians go on to a very broad range of different careers. And it's very difficult, I suppose, for students who do mathematics not to find employment. And that's because they have a very wide range of of skills, and really are becoming a quantitative world, you know, and the ability to work in computer science, the ability to work in finance, the ability to work in, to do with dealing with data, very much skill sets that mathematicians are very, very well designed for, because of course mathematicians learn how to solve problems. Okay, so there's a range of different things. Still, a lot of people go into finance, IT, or further research. I think that's a fair statement of the sort of backgrounds that people go into. And a large number of people go on to further study. That much is true. About 45%, 50% of our students get at least a master's degree. Large number of those get a PhD. You know, we really do tend to choose students who love mathematics, and coming to Cambridge for 3 years or 4 years typically doesn't stop them loving mathematics. And so it keeps on keeping on. Here are two recent graduates. The one on the right in particular, I interviewed, and he was at Churchill, and he is, if you search him out on Twitter, he does the most amazing visualizations of different mathematical things. He worked for Google for a while, and now he's at a different AI company based in Singapore. But of course, people go into work into a whole range of different situations where there's modeling of mathematics is required, as well as scientific journalism. That's a common thing that we've seen happen as well. Okay, so what are your tips for you? I would say the tips for you is really just to encourage your student, your offspring or your ward. Just encourage them, say this is a, you know, if Cambridge seems like an exciting opportunity, just go for it. And, you know, what harm? And you'll fit in, because everybody fits in. And mathematics is very special, separate tribe. You know, maybe you think, oh, well, I just love maths, you know, and I don't talk to people a lot. Well, you know, there's 250 other people who just love maths in your year, and it's going to be great. And then do STEP. Just work on the STEP questions, even if they look impenetrable at the beginning. You know, you can't do an analogy with a marathon really works for me. You can't run 26 miles just straight away, but you go up, build up to 5K, then you build up to 10K, and so on and so on and so on. And that, if you really like mathematics, rather than, as I say, this distinction of being good at mathematics, you like being good at mathematics, but it's not hard to you. If you like mathematics for mathematics' sake and want to be challenged and want to develop it, well, then do the STEP and practice it, and that's the thing to do. So that's what I'd say. Your role is to say, well, if you really love maths, why don't you go for it? And why don't you work at this and work at that, and try those and try this, and access those resources and see how you get on. And remember, we want to let in the students who will benefit the most and learn the most from being here. And so then that's all that we have going on. So yes, I can understand people might be kind of worried about what the interview would be like, but really what happens in the interview is you get the student in and say, hello, and then let's do some maths, right? That's really the situation. You just, hello, plot sine x over x, you know, and then talk and talk and talk. And the thing that I would say about an interview is, and these are some quotes off the student room, is in an interview, the best interviews are the ones where the student comes out and says, oh, wow, that was really difficult. They kept asking me harder and harder questions, and I got stuck a couple of times. And when I got stuck, they gave me a hint, and then I understood the hint, and then I went on, and I just managed to keep my head above water. That's the perfect interview, because that is showing that the student is flexible and was tested and was able to respond to the test. We want to admit students who are good at understanding mathematics, are creative, are flexible in their thinking. We have this jargon word, we call it teachable, because we have these supervision processes, right? You go to the lectures, these 12 hours of lectures, and then you come to a supervision, and in that, every 2 weeks we're associated with the course. And then you've got to be able to, in that supervision, ask the right questions and say, well, I got here and then I got stuck. And then the supervisor can say, well, what you should have thought is this. And say, oh, yes, that's the thing. And so then I should have done this, 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 this. That flexibility, that ability to take a piece of information and run with it is kind of the thing we ask in the interview. And also, if your mind works like that, you are going to thrive in the Cambridge education system. And that's really what we're looking for. we're not looking for somebody who just says, my way or the highway. There's only one way I know how to do this, and I memorize, and da, 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 da. No, that's not going to work within our education system. What we want is somebody who says, oh, that's a good hint, that's a good idea, this is a good idea, this is a good idea. That teachability is what we're really looking for in the interview. It's not that they know the answer to every single question. It is, can they, when they get stuck, can they talk through what it is they're getting stuck on, so then we can help them. So that's another thing to say about in the interviews. Make sure that you practice talking about your thought processes, because then we can tell where you've got stuck and sort of suggest to you a new hint. So that's a very important thing. Work on step. And if you think about the interviews, the important thing to do is think about vocalizing, because it's about half an hour and you'll be asked to do various things, what your thought processes are when you're coming up to a particular idea. There's videos that you can see on the university websites that tell you, show you these things. I think all four of these videos are really good. Just search them out on the admissions pages. And now, going on a little while longer than I had hoped, now it's time for me to stop. Thank you very much for listening. And let's try and review some of these unanswered questions. So, thank you. Right. So, Ursula, how should we do this? Shall I just try and answer these questions, or will you join in?
I can join in as well. I was actually typing answers to a few. I can't keep up. I can't keep up. Maybe I was trying to answer the last one I saw there. I don't understand the concept of pooling. Maybe it's easier to say it in words rather than typing it in. I was mentioning the fact that because applications are made by colleges, sometimes some colleges in one particular year may be oversubscribed. So they find that they have very good students that are good enough to benefit from our, maybe I'll put my camera on as well, benefit from our course, but can't be accommodated by them. It is students that we want in our faculty because they're good. So colleges work together, and that is the pool. They work together so that all students that are good enough to do well and benefit from our course are admitted. And this works because we interview well over 80% of the students that apply to us. So we are able collectively amongst the colleges to actually find out who the students who are good enough to come and benefit from our course are. And if a college can't admit them all because they're oversubscribed, they will put them in the pool, and another college will be, that maybe has more spaces because that year they had fewer applicants, will be able to pick them up. Is that, does that answer the question? And Colm, do you want to?
So that I agree with everything that you've said. Maybe the angle I'd say about the pool is, a student applies directly to a college. The college interviews 75% of the students and then comes to decisions, which can be, this student definitely will not thrive in Cambridge. She will be rejected. This student will do fantastically. We really think we want to take them. We'll give her an offer. And then there is, we think this student is likely to thrive in Cambridge, and in a different year I might have thought we would take them, but just this year we happen to have 10 really good ones. Or slightly differently, it is, well, this year we don't have 10 really good ones, though we were aiming for them. We've only got 8. Maybe the college down the road happened to have some good ones, so we will only do 8 offers at the moment, and we'll go along to the pool to see if by accident this good student applied to that college, and we'd like to take them. So we all go down to, it's often held, it was held at Newnham, held at Homerton, held in a college with a big hall, and we look through the files in January of these pooled students, i.e. somebody has made a judgment, this person might well thrive at Cambridge, but oddly this year we had a strong cohort of students. Or specifically in mathematics, it's not odd, Trinity always has fantastic applicants. And there are some people who apply to Trinity, many people who apply to Trinity, who then are taken by other colleges afterwards, because a student who, the 47th best student to apply to Trinity could be the 9th best student to apply to this other college. So then you are given an offer, not by the college that you applied to, but by a college that is relatively light on strong applicants this year. And then it is as if you had applied directly to that college. And if you make the offer, you will go to the college you are pooled to, not the college you directly applied to. And almost universally, the students say, what a lucky escape that was, that I didn't go to the college that I applied to, but came to the best possible college. So that's the process it was. Now, if I look at some of the, reading the questions, what is your opinion on a gap year for Cambridge Maths if you keep up maths during the year? Gap years, speaking personally, precisely what you have described when I was a Churchill tutor, I would have been very happy with. You've got to keep the maths up. This analogy with the marathon running is very important. You've got to keep exercising your maths muscles, but the gap year can be a very good thing, and it's not a problem if you keep the maths up. But you should talk directly to the college that you have your eye on and ask them, because different colleges have different views on that particular point. Are personal statements given much importance in the application? Compared to other subjects and compared to gossip to my friends in other universities, not as much. We do definitely always read them, but it is very data driven. The reference and your previous performance and the step exam, it tends to be given greater weight than the personal statement at this university. That in no way means that you shouldn't work on your personal statement, because I know at some other universities that may well be on somebody's list, the personal statement is given greater weight, particularly things like the extracurriculars. In terms of jobs, what can they be with a maths degree? A lot of people go into finance. A lot of people go into broadly things to do with data, computing. More recently, a lot of people are going into things broadly in the green sector. You know, the electricity, a particular thing that I'm interested in. You know, modeling demand for electricity is a key component of understanding issues with wind farms, and that's something that mathematicians are very much involved in. Healthcare issues, the modeling of drug trials and so on. There's a lot of that is mathematics related. There is some in the manufacturing sector, but not quite so much. So I'd say finance, IT, education / research is very common destinations for mathematicians. There will be a recording of the webinar and the PPT, that's right. Okay, I'll deal with that in a minute. You mentioned a publication. Where can I get this, please? I hope Ursula will type in the answer to that. What kind of? I will
when I get to it. Publications about what?
I think the publication I said about the preparing for STEP. I think.
Oh yes, of course. I sent a link to the STEP support program actually, which has all the information there, including the book by Stephen Sickles, which is of course a very good resource for preparation.
What kind of job can my child get doing math? I think I've answered that. Is STEP the absolutely best way to prepare the content difficulty exam style of a maths degree? Yes, I think so. Are there any other resources in addition to this that would help prepare? Well, I think I would certainly want to mention Enrich, something that is part of the Faculty of Mathematics and the Faculty of Education here at Cambridge. That has wonderful resources that get you thinking like a mathematician. Some of it is directly STEP, some is just 16 to 19-year-olds. I think that is, both of those are really good situations. In my son's school, UCAS exams have been cancelled and they will be given the teacher assessed grades for UCAS. Would this cohort, having missed 3 or more months of school, be given any special consideration, extension of deadline, etc.? For the cohort, yes. Obviously, this situation is rapidly evolving and deeply uncertain at the moment, but certainly we are thinking about the knock-on effects of the exam disruption this summer for both, well, obviously the incoming cohort in October 2020, and then we appreciate there is a knock-on through 2021. There will be special considerations. they are being planned at the moment. It isn't decided yet. For Welsh applicants, is performance in Welsh BAC also taken into consideration? Performance in examinations in general is taken into consideration. We are not, our focus is principally to do with the mathematical components of study, but it is all aspects of your sort of record is indeed taken into account. Are tuition fees going to increase for European students in 2021, 2022? I don't know. We don't know. At the moment, we do not yet know the answer to that question. We have recently reviewed employment after 6 months of the graduation data on the UCAS website and observed that joint honours helps to improve employability significantly. Unfortunately, could not find data for CAN, as you don't offer joint honours. Have you seen similar stats? Could be internal stats of students taking non-maths elective have better employability. We strongly believe that the purpose of our degree is to teach you mathematics. The point about the joint honour is somewhat complicated, as I said, because of the breadth of our course, you could be doing stuff that would be very recognised, quite a lot of stats, stochastic financial models, data type things. You could be doing something that's very theoretical physics, and we see no signal of any difficulty of our students getting employability. UCAS website, the British education system is extremely heterogeneous, and it is very difficult to draw guiding arguments across all the different university sectors. You know, there are different targets of the different university sectors. So I think our students are highly employable, and there's not really an issue. How intense is the workload compared to other universities? How many hours a day are students expected to study independently? Well, I think I think this is the typical first year's rhythm would be as follows. From 10 till 12, they're in a lecture. It's Monday to Saturday important. They then have lunch. They then would be wise to spend a couple of hours going over their lecture notes directly that afternoon. And then a couple of hours, at least 2 or 3 hours, working on a problem set towards one of the 2 supervisions they're going to have that week. They're going to have 2 supervisions. Typically, an example sheet takes at least 8 hours to work on. So if I have to do 2 of those and I have 2 supervisions themselves, that's of the order of 20 hours for that. 12 hours of which 15, 16, 17 of them are independent. 12 hours of lectures, and then the same amount again to go over the notes. So once again, 12 hours of lectures, 2 hours of supervisions, 12 hours of independent study to make sense of the bloody lectures, and 16, 17 hours of independent study for the preparing for the supervisions. So we are expecting 25, 30 hours of independent study and 14 hours of contact. That's really the pattern of what is expected during the 8 weeks of term in Cambridge. And then also, there is certainly an aspect that they kind of have a catch-up period. You know, there is a break over Christmas, but there's a catch-up. And in particularly over the Easter, there's really solidifying and independent study expected. I don't want to... 4 years I was a lecturer in Bristol. The students have to work harder here than they do in Bristol. Per week. Bristol is a superb university and does a great maths course, but the teaching periods are longer. You've got to be quite intense during the terms, which is why I say you can't really get a job while you're here. Any resources for preparing steps? Yes.
Yes, I think I posted the link for that.
Yeah. And if not, meet the grade 1 for both step 2 and step 3, although it is more likely to get 3A stars. No, you are eligible to apply, definitely. That is the flexible offer. And there are colleges, Downing, Emmanuel, Fitzwilliam, Jesus, King's, Lucy Cavendish, Newnham, Sydney, Sussex, Trinity Hall, and this is all written in appropriate documents, that are indeed, under certain circumstances, saying one grade on either step 2 or step 3 and 3A stars. But you should contact the college to discuss that particular situation. if they can't have a part-time job, how will they be expected to make money to live there? Oh, so I was asked about the costs, and I brought up this slide. It's a little old, but to leading order, it's about, there is a variability from different colleges, but it's about £200 a week is what the students were spending 4 years ago. If they can't have a part-time job, how do they expect to make money to live there? Well, there is a summer. There is also the possibility to get loans, but that is an important point to say. You cannot come to Cambridge and there are, for people who are in means tested aspects, there are substantial amounts of bursary support available from that is university / college specific, but you are not in a position to be able to get a part-time job. Because as I talked through there, it's about a standard level of working is about 45 hours a week. I've heard that engineering at Cambridge is very mathematical. Is there any truth in that? And is there much overlap between the two? So some of my best friends are engineers at Cambridge. The engineering is quite fundamental at Cambridge. It's about understanding, it's a world-class engineering department, but it's really about, trains very well the fundamental science. But there is no overlap at all at the undergraduate education level. There just isn't. We are in the Faculty of Mathematics, they're in the Faculty of Engineering. Their courses are completely independent. Every course, we teach all the courses for maths, and the only separate thing we do is we also teach the mathematics for the first 2 years of the natural sciences tripos. So for physicists and chemists and so on, we teach the first 2 years of their maths course. We have no connection with the educational connection with engineering. Does this admissions process apply for other courses at Cambridge? Yes, as I described, well, yes and no. So it applies in the sense that you apply to a college, you are interviewed at a college, and you will get an offer, or the pool process. What is different is mathematics is unique in having the step exam as the examination that is taken after A-levels. On average, what percentage of students achieve a first? 30%. About fees. Ooh. I might leave the about fees to Ursula to type that. That sounds quite a technical question.
Yeah, there are many questions that I can't type answers to everything now, but I will collect them, and it's all being recorded, so yeah. We'll answer everyone.
Yes. Is it possible to defer a place to take a gap year? Yes. Do you negotiate that? You discuss that with the college, and indeed it is possible to apply to when you apply to say that you're applying for the subsequent year. That is, if this is a question to do with the present circumstance, that is under discussion at the moment, and you should check with your college at the moment if you're referring for October 2020 admission. But in a general principle, it is possible to apply for the year +1. I'm not clear whether choosing a particular college or the open option increases chances of a place. Doing neither increases chances. Doing either, no, you do not increase your chances of a place by doing one or the other. You choose. So why would you choose a college? Well, do you want to be in a big college? Do you want to be in a relatively small college? Do you want to be in somewhere that looks like Hogwarts? Do you want to be in somewhere that doesn't look like Hogwarts? Do you want to be somewhere that's got the playing fields on site? Do you want to have somewhere that's got a jazz band? Do you want to be somewhere that's got a fancy piano? Do you want to be somewhere that's got a recording studio? Do you want to be somewhere that's got its own theatre? Those are the reasons to choose a college, not to optimize your chances to get a place. And as it said, 30% of the students don't end up at the college they applied to anyway. The open is really to reduce stress if you just can't get your head around any decision tree like that. I really would recommend in general that you should at least think about it. Churchill, the perfect situation is Churchill College, the college I work at, was built, it was built in the 50s and 60s, officially opened in 1960. Square outside the town, no tourists around it, but it is a triumph of brutalist architecture. My wife works at Trinity College, founded by Henry VIII, amazing, dreaming, quadrangles, lawns, beautiful Tudor architecture, home of Newton. They're just different. I'm not saying one is better or worse than the other, but they're different. Your chances of getting in is not a function of whether you choose one way or the other. I think we talked through the pooling. I'm
just typing an answer about the third subject.
Yes.
Any preference for the third subject? Several colleges prefer a science as a third subject. Other colleges don't mind as long as it is a solid academic subject, like, I don't know, history, Latin, a language, but people should check with the college where they want to apply to.
Yeah, check with the college that you want to apply to. In mathematics is the thing we are focused on.
Mathematics and further mathematics.
Yeah, and further mathematics. Yeah, the maths and further maths. If my A-level results aren't what I want them to be, as good as A star, A, but I do really well in my STEP exams, will I still be considered for a place?
It's a rare case, actually.
Yes.
I typed an answer to that. There was a case that I remember where somebody missed A star at, I think, further maths or whatever. And it wasn't in my college. I don't know what the reasons were, but they did well instead, but they were admitted. So it does happen. And exceptions always happen because we take into account individual circumstances. But practically all our applicants make their offer at A-level.
Yes, it is unusual, but
it is.
And that is the sort of process that is precisely something that would end up in the summer pool. And then people would look at, we have access to actually the STEP paper that was answered, and then a decision would be made by people. The thing is, an offer is a kind of a contract, right? So if you make your offer, you're in. If you don't make your offer, many students who don't make their offer still get in, but there is an in and out detail about, is there a space? Did lots of students miss their offers? Does this look good on the, is the student reference particularly good? Blah, blah, blah. Students.
I'm amazed how many people, because I've seen lots of answers, questions asking, what if you get many more students, offer holders that you expected, that get their offer? If somebody gets their offer, they're in, as you said. Right. And I typed exactly the same words. It's a contract.
Yes. So there was one, the first year I was director of study, Churchill aims for 14 students in, when I was doing it, we aimed for 14 students. Maybe it's different now, but we aimed for 14 students. And one year we got 19 students because they did well at STEP, and I was just busy that year. That was just the way it was, right? We were expecting about half the people would get their offer. We did more offers than places, and we just had chosen very well that year, and so we had a cohort of 19. It happened. Students who attend schools outside the UK, are the specific requirements regarding marks for each subject? Yeah, we get very experienced about the different things. I come from Ireland, so I was often asked to advise people on what the Leaving Cert grades meant. I actually ended up knowing what the grades from Iceland and Estonia meant. But so we are well used to admitting people from all over the world, and there are spreadsheets with the way that what different subjects mean, what a equivalent kind of performance would be, and what a typical offer would be for people from different countries. Particularly, for example, STEP, IB, there's very often specific requirements on IB, or the EB, the European Baccalaureate, or indeed the French Bac. There's a lot of experience with these different things. What percentage of students complete a fourth year? that's a very good point. So the fourth year is the master's level, the M Math. We call it part 3, but it's M Math. And that has about 80 different courses on a huge range of different subjects. And we typically, once again, have about 250, though this year we actually end up to 300. And the deal is, if you have a first, but I've already said 30% of students get first, you definitely can do it. If you have a high 2-1, you can apply to something that's called the Permissions Committee. And so really, typically about 40% of our undergraduate cohort do the fourth year. And then about 150 or so come in from other universities to do it. Actually, that's what I did. I was not an undergraduate. I was an undergraduate in Ireland, and I came to do I did part 3 quite a few years ago. Okay, so
we are overrunning by about half an hour.
Oh, half an hour. Okay. Did we have anything else to
I didn't realize.
to do? We still seem to have quite a few people present. So
yes.
Does my child need to read lots of maths books for their personal statement or for fair union because the libraries are... Absolutely do not. Reading the maths books is not relevant. When I was reading the goddamn forms, a number of people mentioning, I read this book by Simon Singh. My favorite line of all was, I'm so interested in maths, I have ordered a book by Simon Singh. No, that is not, and indeed doing maths that you can do, like working on STEP, like doing the Enrich things, those are more appropriate than reading popular science books about the Riemann hypothesis or whatever. That's not the thing.
Absolutely. Our reading list is not something that we suggest you should read. It's just a suggestion if you want to read extra maths, but it doesn't matter if you don't read any of the books listed there.
Yes, okay, so I'm trying to, do any of your graduates end up joining the university staff? Yes. Yes, so there are several, we more recently have started to recruit more globally, but Jack Thorne was an undergraduate, Julia Gogg I think was an undergraduate, Katja Berker was not an undergraduate, I wasn't an undergraduate, but but we try and recruit the very best mathematicians, but a lot of people like staying in Cambridge. You mentioned in response to someone else's question that if a student has severe anxiety, they should inform the college they are being interviewed at, but will this lead them to being judged negatively? No. We are trained and we're well, I've interviewed for 14 years. I'm very used to people being nervous in interviews, and it's fine. You do need people to be able to talk, but to do themselves justice. But it is common, not common. We are used to dealing with people who are very nervous in the examinations, and it is in the interviews, and it is very wise to inform the college, because then appropriate adjustments can be made.
Absolutely. Since you're mentioning something about the interviews, and I suppose this will be the last or nearly last question we answer. I saw something, I can't get it now, but I saw something earlier about interviews, assessment being different from one college to another. And so how can this be dealt in the pool? Well, interviews assessments are not that different. All interviewers from all colleges are trained together. And each interview is done by somebody who is an experienced interviewer who has interviewed for that college and for many other colleges. So there is a common standard.
Absolutely. And the typical situation is for, there'll be 2 people present. As I said, to look at the video, I think the video that is on the website is very representative of a typical interview. One person will be asking the questions, and often then the other person will be taking notes, and they ask him, but will be watching, observing the process, and in some way assessing the process. They are obviously, we interview, in mathematics, we're saying we interview, about 1,000 people, right? There is going to be some variability from one place to the next, but we have we are all trained, and we have a principles about what you're trying to do, and we all we have a coherent view on what we're looking for, and so they are as much as possible a kind of standardized process. There is a question I should clarify, a point of clarification. As STEP takes place after interviews, does it mean only those who pass interviews are allowed to take STEP? No, that is not true. You can apply to, you can pay the whatever the sum of money is and register yourself to do STEP. And indeed, there are some people, every year, there are some people who take STEP who are not holding an offer from a university that requires them to take STEP. It's not, it's not a requirement at all.
Of course, that doesn't apply to this year because it's exceptional because of the emergency.
Yes. This year is clearly, well, I shouldn't say it's clearly exceptional. It is exceptional. But I was kind of thinking today that we were talking to people who were year 12s who might be looking, and hopefully things will do settle down. Okay. Well, what should we do?
I think we'll have to wrap things up now, but with a promise that we will collect all your questions and post answers to all the questions that you've asked here. There were questions in the admissions talk and in the STEP talk as well, and we are in the process of collecting everything. And both the answer to these questions and indeed the recording of this session will be posted online on our website and on our new YouTube channel too. So I hope you'll find what you're looking for.
Well, yes. So enjoy the YouTube channel, and I hope you found this helpful. And I hope to be in a position to welcome you all and your children to Cambridge in due course. So thank you, and enjoy your weekend. All right.
Thank you.
Okay.
Bye.
Bye-bye.